This video covers concepts dealing with arrays. Suppose you have 100 students in a class and you need to store their grades and find the class average. This could be accomplished using what we have learned up to this point, but it would require 100 separate variable names. Can you imagine the variable definitions alone? This method is time-consuming and difficult to program. Arrays are the perfect data structure for storing the 100 grades and requires only one variable definition. An array is a data structure that represents a collection of items which are all of the same data type. In the variable definition, the data type is followed by brackets, which indicate that the variable exam score is a reference to an array. An array is an object in Java, so the new keyword is used to create an instance of the array. In the example, 100 memory locations capable of storing a double data type are allocated, and exam score references the array in memory. Each element in the array can be accessed by using the array variable name followed by an index. In a 100-element array, the first element has index of 0, and the last element has an index of 99. In general, an array reference variable is defined with a data type followed by brackets and the user-defined array reference variable. In the example, number list references an array of doubles. The second declaration with the brackets following the array reference variable is allowed. However, it is not the preferred way to define arrays. Once an array reference variable has been defined, then it can reference an array. To create an instance of an array in memory, the new keyword followed by the data type and the number of elements in brackets must be used. In the example, an instance of a 10-element array of doubles is created, and number list references it. To access the individual elements, the reference variable in conjunction with an index must be used. Here, number list sub 0 accesses the first element in the array, and number list sub 9 accesses the last element in the array. Because we start with an index 0, the last element's index is always one less than the size of the array. It is possible to define and create an array in one statement. It is possible to define and create an array in one statement. It is accomplished by combining the array declaration and the array creation with an equal sign. In this example, number list is defined as an array reference variable that can reference an array of doubles. The new double 10 actually allocates the array of 10 doubles in memory. In Java, array elements are assigned default values at the time the array is created. All numeric primitive data types are initialized to 0. Character data types are initialized to the Unicode null character, and Boolean data types are initialized to false. Array elements are accessed by using the array reference variable in conjunction with an index. The first element has a 0 index, and the last element has an index of 1 less than the length of the array. When the exam score array is defined and created, 10 double data type memory locations are allocated and initialized to 0. Each element can then be assigned a value by using exam score subindex in an assignment statement. Here, the first element, which is accessed with exam score sub 0, is assigned the value 99.5. And the second element, which is accessed with exam score sub 1, is assigned the value 87.75. The first 6 elements are initialized in this array with assignment statements. An array index is also known as a subscript. This is where the sub comes from when reading array element notation. Exam score sub 0 means the exam score element with a subscript of 0. Once an array is declared and created, the index variable can be used in the same way as a regular variable. The average of the array elements is computed as the sum of each of the elements divided by 3. An initialization list can be provided at the time the array is defined. When an initialization list is provided, the array is created in memory, initialized to the values provided in the list, and referenced by the array reference variable. When using an initialization list, the array declaration and initialization must be completed in one statement. The shorthand notation in the first example is equivalent to the code in the second example. Once an array is created, its size is fixed and cannot be modified. The length property returns the number of elements in an array. In the example code, number list references an array of 10 double elements. So numberList.length returns 10. One of the advantages of using arrays is that arrays can be processed with loops. The code block on the left is equivalent to the code block on the right. Both populate the array one element at a time and output the array element. Notice the code block on the right uses the for loop control variable as the subscript. This is the perfect looping structure to use with array notation because the subscript is initialized and incremented or decremented by the loop itself. In this code block, an array of 5 integers is created and referenced by values. In the for loop, I is initialized to 1. And then I is compared to 5. Since 1 is less than 5, the conditional expression evaluates to true and control transfers to the body of the for loop. The statement sets value sub I to I plus value sub I minus 1. Since I is 1, value sub 1 is set to the result of 1 plus 0. At the end of the loop, the update section of the for loop is executed. I was 1, so I plus plus sets I to 2. Because 2 less than 5 evaluates to true, control transfers to the body of the for loop. Because I is 2 and value sub I minus 1 is 1, value sub 2 is set to the result of 2 plus 1. So it is assigned a value of 3. At the end of the for loop, the update section is executed, so I gets incremented to a 3. Because 3 less than 5 evaluates to true, control transfers to the body of the for loop. Because I is 3 and value sub I minus 1 is 3, the value sub 3 is set to the result of 3 plus 3, so it is assigned a 6. At the end of the for loop, the update section is executed, so I gets incremented to a 4. Because 4 less than 5 evaluates to true, control transfers to the body of the for loop. Because I is 4 and value sub I minus 1 is 6, value sub 4 is set to the result of 4 plus 6, so it is assigned a 10. At the end of the for loop, the update section is executed, so I gets incremented to a 5. Because 5 less than 5 evaluates to false, control transfers to the statement that follows the body of the loop. Value sub 0 is assigned the result of value sub 1 plus value sub 4. Since 1 plus 10 is 11, value sub 0 is assigned an 11. Once an array is declared and created, it can be populated with user input by using a loop and a scanner object. In this code block, the entire number list array is populated by the user. Notice the index variable I starts at 0 and ends at the length minus 1. In this code block, the loop is used to initialize the number list array with random values between 0 and 100, but not including 100. In this code block, each of the elements in the number list array are output followed by a space. In this code block, the variable total is used as an accumulator. It is initialized to 0 on the outside of the loop so that the first iteration of the loop, the statement total plus equal numberlist sub I, will add 0 to numberlist sub 0 and store the result in total. At each subsequent iteration, the numberlist sub I gets added to the previous total. At the end of the loop, total holds the sum of all the elements in the numberlist array. In this code block, max is assigned the first element in the numberlist array. At each iteration of the loop, the next element is compared to max, and if a larger element is found, max is replaced with that element. At the end of the loop, max will have in it the largest element in the numberlist array. In this code block, the first element is saved so that the loop can shift the elements up one index, starting with the second element. After the loop terminates, the element that was located at numberlist sub 0 is stored as the last element in the array. An enhanced for loop, also known as a for each loop, is used to iterate through an array without using an index variable. The syntax expects a variable defined that matches the data type of the array. At each iteration of the loop, the variable holds the element in the array. It works as if there is an automatically incremented index keeping track of where the program is in the array, starting with the first element and stopping with the last element. In the sample code, as the number list array is traversed, the element is stored in the variable value. So the print line statement actually outputs an element in the array. To traverse an array in a different order or change up the elements in the array, you must use a loop with an index variable. The assignment operator cannot be used to copy the contents of one array to another array. As the diagram indicates, the assignment operator copies the reference of one array to another array reference variable. So after the assignment statement executes, the array reference variable on the left side of the assignment operator references the same array as the variable on the right side. Sometimes this leaves an array unreferenced, so when this is the case, the array gets marked for garbage collection. In order to copy the contents of one array to another, a loop must be used to iterate through the arrays, copying one element at a time. In the sample code block, target array is assigned the elements in the source array, element by element. Arrays are not limited to holding primitive data. In this example, an array of strings is created and initialized. The names reference variable references the names array, and each element in the array references a string object. Similar to arrays of primitive data types, the new keyword must be used to create an array when the initialization list is left off. Notice that when the array is created, each element holds a null reference, which means that the element does not refer to any object. When an array of objects is created without using an initialization list, each element must be initialized. Because each element in an array of strings is a string object, the methods that are used for string objects can also be used on the elements in arrays of strings. The syntax must include the array reference variable and the index of the element. In the first example statement, the string referenced by name sub 0 is converted to uppercase, so John in all caps is output. In the second example, the first character in the string referenced by name sub 3 is assigned to letter, so letter is assigned an uppercase F. When dealing with arrays, length is a field and returns the number of elements in the array. No parentheses are used after the length field in an array. When dealing with string objects, length is a method and therefore must include parentheses. The example code will iterate through the names array because names.length returns the number of elements in the names array. At each iteration of the loop, the length of the string referenced by the element is output. A two-dimensional array is an array of arrays. Each row is a one-dimensional array. It is easy to visualize a two-dimensional array as a matrix. Declaring a two-dimensional array requires two sets of brackets and two size declarators. The first size is the number of rows, and the second size is the number of columns. The two sets of brackets after the data type indicate that the variable will reference a two-dimensional array. Notice that each size declarator is enclosed in brackets. To process the data in a two-dimensional array, you must use two subscripts. The first subscript is always the row subscript, and the second is always the column subscript. To assign a 95 to the element at row 2, column 1, you must use the array reference variable grades, followed by the row subscript, then the column subscript, both in brackets. So, grades sub 2, 1 equals 95 places a 95 in row 2, column 1. Nested loops work great when processing two-dimensional arrays. Here, the outside loop iterates through each of the rows, while the inside loop iterates through each of the columns. Therefore, for each row, every column is populated with user input by the inside loop. In this sample code, the nested loops output the data in the grades array in row order. In other words, for each row, each of the column elements are output. When the inside loop has iterated through all of the columns, it terminates and forces the outside loop to begin its next iteration. Therefore, for row 1, each of the column elements are output, and so on. An initialization list can be provided for a two-dimensional array. Each row's initialization must be enclosed in its own set of braces. Notice that no size declarators are given. Java uses the initialization list to determine the number of rows and columns in the array. Two-dimensional arrays are actually arrays of one-dimensional arrays. So when the length field is applied to the array name, it returns the number of rows in the two-dimensional array. Each row has a length constant that holds the number of columns in the row. Each row can have a different number of columns. To access the number of rows in an array, use the array name.length. In the example code, numbers.length returns 3 because there are 3 rows in the numbers array. To access the number of columns in an array, use the array name subrow.length. In the example code, numbers subrow.length returns either a 4 or a 3 depending on the row subscript. To compute the sum of all the elements in a two-dimensional array, use an accumulator and nested loops. In the example code, numbers is defined as a two-dimensional array and initialized with an initialization list. The accumulator total is defined and initialized to 0. The outside loop iterates through each row, and for each of its iterations, the inside loop iterates through all of the columns. In other words, when row is 0, the column loop repeats for column equal 0, 1, 2, and 3. At each iteration, the element is added to the accumulator. So after the first complete iteration of the outside loop and all of the iterations of the inside loop, total holds a 10, which is the sum of the elements in row 0. After the outside row loop has iterated through every row, the total variable holds a 78, which is the sum of all of the elements in the two-dimensional array. To compute the sum of each row in a two-dimensional array, use nested loops and initialize the accumulator inside the outside loop. By doing so, it will reset to 0 for each row. In the sample code, for each iteration of the row loop, total is set to 0 and the inside loop repeats all of its iterations. After it completes, the total of the row is output. So for the first iteration of the row loop, total is set to 0 and the inside loop completes all of its iterations. Then total of row 0 is 10 is output, which is the sum of all of the elements in row 0. The outside loop moves to the next row, which is 1. And then the inside loop sums up all of the elements in row 1. After the inside loop completes, the total of the row is output. So when row is 1, total of row 1 is 26 is output. And likewise, when row is 2, total of row 2 is 42 is output. To compute the sum of each column in a two-dimensional array, reverse the order of the nested loops by placing the column loop on the outside and the row loop on the inside. Initialize the accumulator inside the outside loop. By doing so, it will be reset to 0 for each column. In the sample code, for each iteration of the column loop, total is set to 0, and the inside loop repeats all of its iterations. After it completes, the total of the column is output. So for the first iteration of the column loop, total is set to 0, and the inside loop repeats and completes all of its row iterations. Then, total of column 0 is 15 as output, which is the sum of all of the elements in column 0. The outside loop moves to the next column, which is 1, and the inside row loop sums all of the elements in column 1. After the inside loop completes, the total of the column is output. So when column is 1, total of column 1 is 18 as output. And likewise, when column is 2, total of column 2 is 21 as output. And lastly, when column is 3, total of column 3 is 24 as output. Not all rows of a two-dimensional array must have the same length. When each row in a two-dimensional array has a different number of columns, the array is known as a ragged array. Ragged arrays can be created by defining a two-dimensional array with a set number of rows but no columns. Then each second dimension can be created individually. Java does not limit the number of dimensions that an array can have. However, anything beyond 3 dimensions is very difficult to visualize. For the purposes of this course, we will only work with 1- and 2-dimensional arrays.